But anyways, thank you everyone for joining us for today's little discussion. Over the holiday break here in North America, in the United States specifically, it's been hectic. And before that, we had KubeCon, which is really what we're going to be double clicking into today. And really kind of some of the takeaways that we had at Magalix, and I think the industry as a whole has had. And really today, I want to introduce Tony, who's going to be talking and taking you mostly through the conversation today. But Tony is a solutions architect here at Magalix. He's one of our engineering leaders and really a pillar in our practice. But before Magalix, Tony was a cloud native practitioner through and through. He was a technical advisor as well, AWS and Kubernetes certified, and a pretty good author as well. I haven't read all his work, but I know it's out there. And then you have myself. My name is Daniel Tarani. I'm an account manager here at Magalix. Don't worry, I won't be talking too much. But I come from HashiCorp and Platform 9. I've been in the cloud native space for a while, really talking about Kubernetes back in 2016, and then the HashiCorp suite. In the last 2 years, I've spent actually doing DevOps consulting on the Fortune 500, working with clients such as JP Morgan Chase, US Bank, and a few others. And now I find myself here at Magalix and really riding the big wave of cloud native and what's going on. But what I'd like to do is kind of show you guys the agenda for today's and what we're going to be talking about. So really, we're going to start off with kind of the state of the union of KubeCon, if you will, and how it's just more than a virtual shift. I think there's a few things that really jumped out at me, jumped out at Tony, and jumped out at our team that really left an impression. So I definitely want to highlight that and kind of a recap, but then really passing the ball off to Tony and guide you guys through the policy as code and the refresher, the shift left. Tony will be talking about that. And then focusing on our incubator project that we're going to be double clicking on today, which is OPA, Open Policy Agent. So without further ado, let's take a look at KubeCon holistically here. And the few things I want to focus on, number one being execution, right? And like I said earlier, it's more than just a virtual shift. For those of you who were at KubeCon Europe and now KubeCon North America, us, of course, Magalix on the vendor side, we saw a few things that really changed and really stood out to us. Number one was the execution. I think from keynotes to just the ease of navigating the site, it was far better. Keynotes were pre-recorded, so they were a lot cleaner. And really, a plethora of amazing content because people had the chance to plan it out and really put their best efforts into it. So that was an awesome takeaway from KubeCon North America, and I hope that it continues as they've slated the next KubeCon in Europe to be virtual as well. Secondly, attendance. Over the last 5 years, we've seen KubeCon and Cloud Native Con really grow. I remember the first one was about 500 attendees, and I believe the round number is right around 25,000 for this last one that we just had. So it's a huge nod to the flag that we're waving with Kubernetes and kind of the Cloud Native. But we're seeing the industry go from a trend, right? And we're seeing involvement from not just startup companies, but companies that are a little bit more mature and have a little bit more going on. So that's really exciting. And that leads into Kubernetes is growing. Right, it's becoming the de facto standard. As you can see by the projects alone, right, we have 40 sandbox projects, which is spectacular, and then 21 incubating projects as well, right? So growing on the project front, it's almost a little hard to keep up, but thankfully they're being a little bit kinder to the community as well. We went from 4 releases a year to down to 3. So again, being a little bit more conscientious of the community, trying to keep up with all the features and kind of the new lingo going on with Kubernetes. So it's been pretty phenomenal. All in all, I thought it was a great show, but something that we came back to was the few themes that really jumped out at us. Among them was, of course, chaos engineering was talked about quite a bit if you guys were there. Service mesh was talked about, but what really jumped out to me, and I think a lot of us here at Magalix, was really 2021 is shaping up to be the year of the policy. And what do I mean by that, right? It's policy as code. Not only are we talking about it here at Magalix, but we saw a number of startups and even more mature companies making that shift to the verbiage of policy as code and kind of codifying and that kind of vernacular, really moving that direction. And how everyone's defining it too. You have people saying policy as code, people saying environment as a service. There was a few understanding governance as code, right? And really, I think what we're seeing is in 2021, there's a huge emphasis on the fact that DevOps is kind of shifting over to DevSecOps, right? And making security a thought throughout versus an afterthought. I think Tony's going to be touching that on a little bit, but really, it's nice for us to see at Magalix because we've really built our business off of the idea of governance as code and making sure that you're able to optimize your resources, distribute your policies, and enforce your workflows across your teams, regardless of your Kubernetes infrastructure, right? So with that, guys, it's a quick introduction. I'd love to pass the ball off to Tony. And Tony, if you want to take it away and guide us through, that'd be lovely.
Awesome. Thank you, Dan. And so, we're going to start here is just a quick refresher on policy as code. And so thinking about this and thinking about your organization as you scale from tens of pods on one cloud provider to, hundreds of pods spanning across several cloud providers, there's no way you're going to be able to secure everything by hand. Much like how we use, config management and infrastructure as code to deploy at scale, the same needs to happen with security. And so policy as code allows us to scale security pretty much alongside everything else. And in this day and age where privacy is key and security is key, it can no longer be treated as an afterthought. And since now with emerging open source technologies, because policy is code, we have the opportunity to bake it into our existing development pipelines. And so one of the huge problems, one of the problems that this will solve is basically how do we incorporate security while continuing to take advantage of cloud native and DevOps practices. And so to me, one of the biggest takeaways from KubeCon is shifting left. And, when I first heard this term, I thought it was just basically throwing the responsibility back over to the developer. But in actuality, it's really about gathering feedback, not only earlier in the process, but immediately when feedback needs to be given. And to dive into that a bit deeper, let's take this scenario, right? We all know that DevOps and cloud native, has brought alignment and automation to accelerate your business to get, your latest features out to your users. But, in this common scenario, typically, time and resources aren't budgeted for security. And so usually what happens is somebody finds out there's a vulnerability, or maybe somebody outside your organization lets you know, it triggers or warrants an investigation into, looking at what's going on, and that gets back to the developer. And so as you can see, that kind of goes against the DevOps idea of, moving quickly, right? And so maybe, or if you're in an organization potentially that, has security resources allocated, this diagram could, even represent your staging environment. But at the end of the day, you could still see here that the purple lock represents, what people normally think is, security as a hinderer, right? If you think about this even deeply, even Kubernetes itself has followed, a model similar to this. If you think about, security being implemented in Kubernetes, specifically role-based access control, RBAC, that didn't even hit beta until version 1.6, right? And that was 3 years after the release. And so, this is a very common practice I see happening a lot, right? But, as you know, times are changing. And so as we talk more about shifting left and policy as code, you can see in this diagram that we are literally shifting left, right? In this way, and the way it was before, your developer is probably already working on the next big feature by the time they're aware that there's some kind of security vulnerability that they need to address, right? And so even the context switching alone is pretty brutal, right? And it lowers productivity. And, again, that goes against kind of, what DevOps is all about, is about moving quickly and being agile, right? But, as of late, more open source tools have become available. And so now you can incorporate your security efforts, because it's code, into each step of your, deployment pipeline. And to walk through this image very briefly, your developer creates, create a new feature. They build a Kubernetes manifest, and they have local tools that they can run at the commit time to see whether or not they are in compliance. And so as they feel comfortable and it's passed tests, it moves to your Git repository where CI/CD picks it up, and then depending on what you're doing there, you could run a whole suite of full regression tests based on security. And then if those pass, it goes into Kubernetes. And then when you deploy your Kubernetes cluster, you have other new tools in there that are constantly monitoring and scanning to ensure that nothing is out of compliance. And then obviously, you're probably sitting your Kubernetes on top of a public cloud somewhere. That public cloud comes with its own set of tooling. And so ultimately what you're seeing now, not just in security, but across cloud native, is that shifting left is not necessarily just for dev teams anymore, right? And security is not just for security teams. And so, looking at this model, the person on the left can either be a developer or it could be a DevOps engineer or SecOps engineer, anyone that's really touching code, right? And so, if you look at this model, really everyone has a stake in the security game. And we'll talk a bit more about this in depth in a later slide. And so, as you know, there were about 9 sessions at KubeCon that really were focusing around policies, code, and security. And so in this section, I'm going to talk about 2 scenarios that you may not have known that OPA was capable of doing. And so the first thing that, one of the first sessions we saw were OPA bundles. And so if you're running multiple pods, OPA policy management won't really be that big of a chore, right? You have a couple pods, you're running potentially OPA as a sidecar using kube management. It's very easy to manage. But once you start growing, especially if you're growing exponentially, the problems of managing individual pods, coupled with individual OPA policies becomes, a bit nightmarish. Right? As you can see in this diagram, you have a mesh of services, and if each one has their own individual policy, it's kind of hard to keep track of what's going on. And so some of the challenges here are, how do you distribute policies, to each individual OPA instance? Then how do you keep those policies up to date? And then, when you're updating them, how do you ensure that during that brief moment, you're not insecure? And so what OPA provides is they provide a feature called bundles. And so with bundles, basically you can create your own policies, sign them. And since it's code, you can leverage your CI and CD systems to, test your policies and then push them out to any accessible location, for example, S3. And so then what happens is the OPA agent gets to manage its own policy lifecycle, right? Because built in, it'll periodically check for any new updates to its policy. And since the bundles are signed, you'll know if those packages have been tampered with, right? One cool feature that OPA provides is sort of a hot reload feature. So as OPA, queries your repository for any new updates, and once it sees it and downloads it, it'll hot reload those updates. So there's not a moment where you'll be left, unsecured. So definitely check out the link below and see if bundles make sense for you. A second feature of OPA that most may not know about is, OPA is extensible, right? It's code, and OPA may not necessarily cover every single use case that you could think of. But that's okay, right? Because, sometimes you may be in a situation where you might be saying, well, OPA would fit my use case, but if it added this, or if only it could do this. But, because it's extensible, because it's code, it's open source, you're allowed to build your own custom logic, right? And so, that logic can be, as simple or as complex as the situation calls for. But knowing that you can extend OPA and build your own is pretty powerful, right? And so, one big takeaway from the session here is that, even though you may think that your use case is very unique, it may not be as unique as you think it is. So the committers are encouraging folks to, go to the GitHub repo, open up an issue, engage with the community, and build a solution and potentially give back because maybe somebody else could use your expertise down the road. So shifting gears off of OPA a bit, I know that's the hot topic, but there was also a session about zero trust infrastructure. And so, let's talk a little bit about how that fits in with policy as code. So just to give a brief intro about zero trust infrastructure, if you've never heard this term before, back in the day, before everything was connected to the cloud, you had a corporate LAN, potentially with a firewall that led to the internet. And, if you knew something about security and, layer 3, layer 4 networking, you would build like a DMZ. And so you would have this kind of perimeter security, building a moat, or it's called maybe eggshell security, where, all you have to do was protect around the edge, right? But, as you know, with cloud native and everything wired up and, multi-cloud and touching a bunch of different SaaS services, this model is no longer sustainable. Like I couldn't even tell you what the moat would be protecting because everything is kind of everywhere, right? And so, kind of, leaving that for the old school and looking at things from kind of a cloud native perspective, we're looking at things that are more about, it's more about defense in depth, right? And defense in depth is an idea that, if one component is compromised, there are other mechanisms in place to prevent it from, compromising more things. So essentially, let's say, for example, somebody has hijacked a container, part of a pod that's in my Kubernetes cluster. Can that then spawn, other pods or other child processes, right? And if you apply defense in depth, I would have another mechanism in place that will prevent any rogue, black hat hacker from, attempting to, spawn up a botnet or something like that. And so, because of this, and putting zero trust infrastructure together, we basically have to secure all of our workloads across all of the systems we touch. And in this case, a workload could be anything. It could be, your Redis instance. It could be your SQL database. It could be your microservice. It could be, a third-party, auth system like Auth0 or something like that. And so, what has come about are really a protocol and kind of an implementation. And so that's where Spiffy and Spire kind of come into play. And so basically Spiffy is a framework or for how to authenticate your workloads. And Spire, in this case, is the implementation. So an example of this would be if any of you are running, excuse me, a mesh, service mesh in your Kubernetes cluster, Istio, Envoy, they implement Spiffy to basically handle mutual TLS. And so, at this point, you might be saying, well, this is really infrastructure. This is not really, policy as code. Well, technically it is code. And again, just like OPA, this is extensible, right? You can build your own implementation. And they also offer libraries in C++, Go, and Java. So if you're in the need for any type of authentication, you could build your own solution. Excuse me. And to be a bit more concrete of how people are using this in their organization, not at this KubeCon, but a couple of KubeCons ago, there was a talk about Spiffy and Spire. And one organization used Spire. They built their own authentication mechanism using Spiffy to authenticate to their HashiCorp vault to get their database credentials, right? And because it's auth and because it's code, you can see how you could use that in a lot of places, right? So if we go back to the example of somebody hijacking my container and running a rogue process, if I try to then, talk to the HashiCorp vault, I can't because, nothing is there to authenticate me. And so, if you're in the need to build a highly secure infrastructure, definitely check out Spiffy Inspire, and you can come up with ways to use it in your unique use case. And so another takeaway from KubeCon is DevSecOps, right? And I know that this could be looked at as another big buzzword in the industry, but let's really dive deeply and see just what this means, right? And if you look at the last two examples, what we've really done is, we're talking about securing our components, but we're talking about building trust and security, within our own components, right? What we really haven't done is secured any components really outside of our stack, right? And then knowing now that there are tools to incorporate security into our DevOps practices, we can definitely add this word into our DevOps terminology, so we can remind ourselves not to treat security as second class. So we're going to divide DevSecOps into two sections, right? First, there's DevSecOps from a build perspective. And so what do I mean by build perspective? I mean, from the time your developers start writing a feature all the way to your container gets packaged, right? So when you think about security in this manner, you think about, okay, what's involved in that? First there's your, the custom code that you're writing, right? Are you building any vulnerabilities in your code base? For example, if you're building a node service, right? And let's say in this service, you're using a bunch of packages from NPM, right? What do? You go to the internet or NPM repository, you look for your use case, you find the package that best suits your needs, and you put in your package JSON and you go to town. And then lastly, as your developers are building their container images, what do? They go and they're probably using the Node Alpine Slim package or something like that, right? And so all of these components put together, at that point, no one's really thinking about, are these things secure? They probably look at, hey, a lot of other people are using it. They just, you just assume that they're secure, right? And this presents challenges, which we'll get into in a later slide. So kind of following up on the DevSecOps on the second half of it is your runtime, right? And so, after your container is built and you deploy it, there are additional challenges that you need to be aware of, right? And the first one is, enforcement of runtime. Are my policies as code, are they being enforced, right? And even if they are, can I do other things that I'm not supposed to? So how do you ensure that you're checking this? And so when you're deploying at scale, you have hundreds of pods across multiple clusters. Again, you can't do this by hand. It's impossible, right? On top of that, how are you continuously checking for new vulnerabilities that are discovered, right? If you think about the components at build time here, the image, the dependencies in your code, what if there's a new CVE identified in one of the packages you're using? Is it, are you affected by that particular version that you're using? How do you make sure that you're still secure? And then finally, how do you make sure that you're auditing all of the stuff, right? You need to know who's doing what, who's making changes, are those changes approved or not? Can somebody, audit, edit the logs themselves to, hide their tracks? These are all concerns, and, it's complex and it's hard, right? There's a lot of moving pieces. Cloud native is not as easy as people may make it out to be. So these are all the factors that you need to think about as you are, trying to secure your cloud native applications. And so kind of putting all the things that we talked about together, this is just an example. I'm not recommending any of these products except for obviously Magalix, but it's just an example to show you kind of how you would put this all to place and to kind of break down the complexity a little bit, right? And so if you look on the left here, you have someone that's managing, your custom code, the dependencies of that code, your Kubernetes manifest, whether they're deployments or services or virtual services, depending on if you're running Istio or not, or service mesh, and then your Docker file. And so in this particular example, we're using GitLab as both a source code repository as well as a CI/CD solution. And so what happens here is, let's say, for example, your developer has no local tools that they're using. They just build the code and they just push it up as quick as possible. Well, then, once your pipelines are developed, what you can do is GitLab provides a tool called SAST, which is called Static Application Security Testing, which supports your modern day programming language, which will basically scan your custom code and let you know if there's any red flags there. And if there are, you can fail the build and have the developer be notified right away, thus reinforcing that idea of earlier feedback and fast feedback, right? And if that pass, we're moving on to another offering they have called dependency scanning, which basically looks at your packages and see if there are any vulnerabilities identified there. Moving on to your Kubernetes manifest, if you're running OPA or Gatekeeper or another solution in your runtime, then you want to make sure that your Kubernetes manifests are compliant. An easy example of this is maybe your developers are running, they believe that these containers need to have privileged access in the security context. But from a corporate standpoint and from a security standpoint, that could be a no-no, right? So how do you verify that? You could run something like conf test, right? And then ultimately, are the containers that you're pulling from Docker Hub or whatever source, are those going to be secure? And so you can use a solution like Anchor to say, to run scans there. And if all of those pass, then you have some confidence that your containers somewhat secure. And so moving on in our example here, those packages get pushed to Amazon ECR because we're using AWS, and your ECR is a private registry, so you have some security there, and obviously you want to throw in your IAM roles. And then so when you're ready, excuse me, in this scenario, we're using Spinnaker to deploy. Spinnaker is also a service that's probably running in a Kubernetes cluster somewhere. And so, that needs security of its own. Can it, maybe using RBAC to say, hey, does this service account actually have the rights to deploy stuff, or create deployments, right? And so once you have a deployment, now you're getting into the runtime scenario that we talked about, which is, now that it's in there, how do I continuously monitor and ensure that, the components or the workloads that I've deployed are, remain secure? And so you can use tools such as Magalix, OPA, Service Mesh Spire, Falco if you're doing any kind of auditing on a system level. And also not to forget here are baked in Kubernetes network policies and your PSPs there. And so now you can have sort of this end-to-end solution where not only are you tackling security from a build time perspective, but also runtime perspective. And all of this is done because, the policy is code. And then at the end here, we have the S3 pointing to OPA, and that's an example of maybe if you're using OPA bundles, right? So not only are you now covering the use cases of your internal services and kind of the surrounding infrastructure, you're also ensuring that your OPA policies are up to date. And that could include something like, maybe one of your services needs to pull, a JSON web token from Auth0, but it needs to be done in such a way, that's where maybe your OPA and your up-to-date policies make sense, your bundles make sense. So kind of, where does Magalix fit into this picture, right? And so Magalix has a feature called KubeGuard, which is currently both actually a compile time, a build time, and a runtime solution. And so if we go back to this diagram here, let's remove GitLab for a second, and we can put in Magalix. Based on your policy, once your repository, or excuse me, your CI/CD pipeline begins, you can trigger Magalix KubeGuard, which basically calls out to our API, and then immediately lets you know whether your, for example, your manifests are compliant or not. So again, reinforcing this idea of, fast feedback and feedback earlier in the pipeline. And then so moving on to more of a runtime solution, Magalix also offers KUBEADVISOR, which in this case is at a cluster level, which based on the policies that you provide and some best practices out of the box policies that we also provide, we give you a snapshot from a cluster perspective of any violations or compliance issues that are currently going on inside your cluster. And then so if we drill down in particular, let's say, for example, you have containers running as root, which we have a default policy for. You can drill down to that, identify how many of your Kubernetes entities are out of compliance, and then click on one of those. And then in our KubeAdvisor, we not only show you where exactly the issue is, we also give you recommendations on how to address the issue. And so, kind of how does all of that work? In this particular case, we have, I just mentioned our built-in policies. We have one that's called container running as root that you can enable here. As you can see, it's enabled here on 2 of our clusters. And, every so often, the Magalix agent will go and scan your clusters, or you can, trigger your advisor to run, on the fly. So just to recap and put all of this together, we talked about policy as code, how now that it's code, you can scale security along with the rest of your, DevOps solutions, right, in your CI/CD pipelines. We talked a bit about shifting left, which is not only getting fast feedback, but also getting it earlier in the deployment lifecycle, right? We talked about extending OPA, not only to deploy your policies at scale, but also to build your own binaries, to custom binaries to suit your particular use cases. We talked about building a zero trust infrastructure using Spiffy and Spire. You just saw how we can add sec into DevSecOps by looking at things from a build time perspective and a runtime perspective. And then ultimately the big picture of how kind of all of these solutions come together and how Magalix can help you out with those challenges.
Awesome.
Yeah, and that brings us to a conclusion.
Thank you, Tony, for walking us through that and getting so in depth, right? That's a lot to cover, and it's a technical topic all its own. But we do have a few questions coming from the crowd here, and actually, I think we can lump these a little bit together here. But questions for you, Tony. Number 1, what is the best way to get started using OPA, and maybe some of the best practices with OPA on top of that. And then lastly, is Magalix compatible with OPA, right? If you can maybe take those 3 questions and answer them holistically there, that'd be wonderful.
Yeah, absolutely. Well, number 1, Magalix is, we're compatible with Rego. And so what is Rego? Rego is the declarative language that OPA leverages. So, for all intents and purposes, yes, we are compatible with OPA in that sense. So you can take your Rego policies that you're working with OPA, and you can, build custom advisors in Magalix, and yes, use those policies. And so, taking a step back, what is the best way to get started with OPA? So, the first thing I would do, the way that I got started is, go to their GitHub repository. There are a lot of examples there that show you, how to apply those policies in kind of what's turning out to be the best practices. So, to give an example that pretty much is universal, let's say you have some governance, a governance policy in your organization that says, every deployment needs to have CPU limits defined, right? Well, there's definitely an OPA policy in their GitHub repo that covers that. And the best way that I would get started is, build yourself Minikube, right? Use Minikube or Kind or any of these, or if you have a test cluster available, apply these policies and, deploy a test service, without those and see what happens, right? Get them, get involved in your Slack channel, the community. I've asked questions in there, right? And they're definitely, there's definitely people in the community that are willing to help you, especially if you're just trying to get started and just kind of wrap your head around Rego, the language, and just, what OPA is and what it can do, right? And so kind of taking that to the next step, what are the best practices? Take a look at the repo, take a look at, what the policies are there. I would say those are probably, generally considered as those as best practices. And you'll see things that are like, don't run your containers as root. Make sure you have CPU limits, and requests, memory limits and requests. Maybe in your organization, you want to enforce labels, right? There's all types of examples there, right? Coupled with the Kubernetes documentation. And so, I think that'll give you a good idea of, kind of out of the box best practices. And then ultimately, I think what it really comes down to at the end of the day is, what is your organization worried about the most? And what do they have to comply with? Is there government regulation? Especially if you're in the finance sector or even healthcare, right? It's HIPAA, SOX 2, all these, all of these other regulatory compliance that, come from, high above. How do you ensure that, those are maintained while implementing, policies of your own? So, on top of what the community is providing, which I say are best practices, it really comes down to, also what does your organization have to be concerned with? So hopefully those answer everyone's questions in depth.
No, thank you for that, Tony. It's a lot to shed light on, and it's an interesting topic, right? I think next year we're going to be expanding on this and talking about it even more. I don't see any more questions from the crowd, so I'm going to take a pause for a moment. If anyone else has any more questions, please type them out, and then we'll give it a moment here. Alrighty, looks like that was it. Well, Tony, thank you so much for joining me today and really leading the charge. It was a fun KubeCon. It's interesting, right? Part of me wishes that we can go back to the live shift, but another part is it's actually kind of nice because we got a much wider attendance this year than we have in years past, and the fact that we were limiting the travel and things of that nature, people could just log in online. It's quite beneficial for those of us who are a little bit more remote than others. And I look forward to the next one. But if there's no other questions, guys, I think we're going to wrap it up. This was recorded and we will share it with everyone. Thank you for everyone's time. Thank you for joining. And we look forward to seeing you on the next one. Have a good one, guys.
Thanks, everybody.